Dear students, let us begin with the 3 marks questions from the chapter Integrals. And I would like to solve the questions from the 3 model question papers sent by the PU board this year. For example, from model question paper 1, you can see the question: integrate x by x plus 1 into x plus 2 with respect to x by partial fractions. That is, integration symbol and dx they have not given. We have to write. Say, I will start here by writing integration symbol, then by writing this integrand full. This is called integrand. Then let me write dx. And they only have said in the question, follow partial fraction. So I will go to my rough work side, but even though I will write it in rough work side, in the examination it should be shown. First I mentioned the rule. So the rule says, if any proper fraction is of this kind, px plus q by x minus a into x minus b, then this can be resolved into partial fractions on the right hand side as unknown a by x minus small letter a plus unknown b by x minus small letter b. Therefore, our integrand, this one, looks like this. Therefore, now I will begin. Say x by x plus 1 into x plus 2 we have. This can be written as, say, unknown a by, see, here we have written x minus a. Now in place of x minus a, I have x plus 1. So a by x plus 1 plus b by second linear factor x plus 2. And this I call as equation 1. And my aim is to find a and b. To find a and b, there are different methods. I will teach very basic method, that is LHS I will keep same. On the RHS right hand side I will take LCM. Therefore LHS same, x by x plus 1 into x plus 2, and on the RHS LCM means multiply both the denominators if they are unlike. Yes, they are unlike. X plus 1 into x plus 2 I will multiply. And now the numerator, let me write. So x plus 1 present over here, but x plus 2 not present in the denominator of a. Therefore, x plus 2 multiplied to a into x plus 2. Similarly, there is x plus 2 present in the denominator of b, and not x plus 1 present. Therefore, x plus 1 multiplied to the numerator of second, that is to b, and thus b into x plus 1. This denominator gets cancelled on both sides, and I get one important equation: x equal to a into x plus 2 plus b into x plus 1, and this is called, I have a practice of writing this as equation star. Now my aim is to find unknown capital A. See, here I will make clear division. A. To find A, my dear students, please make the other term 0. Which is the other term? B into x plus 1 0. B cannot be 0 because B is unknown. Therefore, put x plus 1 0 in equation star. See, put x plus 1 0, that is x is equal to minus 1. This comes here, minus 1 in equation star. See, I have written equation word spelling short form, equation star. So left hand side, put x minus 1. Say x minus 1. Right hand side, capital A as it is, x minus 1 plus 2, and this term we only made it 0. Therefore, what is remaining? Isn't it minus 1 is a into, this is 1. Therefore, have you got unknown a is equal to minus 1. Say, first unknown is ready. Now I will teach you how to find the unknown second one, which is capital B. To find the unknown, my dear students, capital B, go back to equation star. And don't put now x plus 1 0, but make first term 0, not a equal to 0. A is minus 1. but put its coefficient 0. What is the coefficient of a? X plus 2 equal to 0. So I will write, put x plus 2 is equal to 0. That is x is equal to minus 2 in equation star. What we get? When I put x minus 2, left hand side becomes minus 2 of equation star. First term we only made 0 plus b into x is minus 2 plus 1. Therefore this implies minus 2 is equal to minus b. Therefore b is plus 2 here. B is plus 2. And therefore let us substitute both a and b back in equation 1. Wait, I will come back to the main side. Therefore, what is this integral of? Inside bracket I will write. What is the integrand replaced by? X plus 1 into x plus 2. It is replaced by capital A by x plus 1 plus capital B by x plus 2 into dx as it is. This can be rewritten as integration of, say, capital A we got minus 1 by x plus 1 plus capital B we got plus 2 by x plus 2 dx, and these can be integrated. How? So first one is the integration of minus 1 by x plus 1 dx. In the second one, it is integration of 2 by x plus 2 dx, or this becomes minus as it is, my dear student, minus 1 as it is. What is the integration of 1 by x plus 1? It is a generalized standard form. Integration of 1 by x plus 1 is log of mod of x plus 1. I will write here log of mod of x plus 1, of course to the basic. Here see, first take 2 outside. What is the integration of 1 by x plus 2? Log of mod of x plus 2 basic plus c. Or this can be simplified further. This can be written as minus log of mod of x plus 1. This 2 can be written to in the power of x plus 2. That is by using third law of logarithm. There is a law of logarithms called n into log m. N into log m is log of m power n. Therefore, this is log of mod of x plus 2 whole square basic plus c. And now this can be rewritten as, this looks like a positive term, log of m minus, this is negative, log of n. Therefore, this can be written as log of m by n. Please go through the answer. Here is the second question. 3 marks from model question paper second. So integration of x into tan inverse x dx. And the moment you see this question, say integrand is a product of 2 functions, x and tan inverse x. So we have to apply integration by parts rule. So in my previous video, I explained integration by parts rule. Here in the rough work side, I would like to mention once again. So integration by parts rule. Say integration of u into v into dx. That is first into second is equal to first function u into integration of second function v dx minus within integration symbol, open the bracket, d by dx of first function u, integration of second function v into dx, close bracket dx, and here the order of the functions must be determined according to I-late rule. I-late rule means here I stands for inverse trigonometric function which is present here. Say tan inverse x. L stands for logarithmic function which is not present here. A denotes algebraic function which is present here. Say x. Then t trigonometric functions, e exponential functions. Let it be. Therefore, first which one should come? inverse trigonometry function. Therefore, listen, dear students, I will rewrite this question as I equal to, I means my given integral. I will rewrite according to Eilert rule. Tan inverse x is my first function into x is the second function. So what is tan inverse x? Tan inverse x is, say, I will write here in small ITF. ITF is the short form of inverse trigonometric function, and this x is algebraic function. Algebraic, and you know, according to the rule, this should be first function and this should be second function. Thus, I would like to apply integration by parts rule. Say, so it says, the rule says it is equal to first function. Say tan inverse x into integration of second x dx minus, open integration symbol and open a bracket, d by dx of first function. Say tan inverse x into integration of second x dx, close full bracket, into dx. Wait, therefore this is tan inverse x into, say, integration of x power 1 dx, x power 2 by 2, x square by 2, minus, within the integration symbol, you know, differentiation of tan inverse x from memory, 1 by 1 plus x square, integration of x dx, see, x square by 2, last into dx over here. Therefore, this term as it is, tan inverse x into, it is x square by 2 as it is, minus, do you agree? In this, say, 1 by 2 is common. See, I will repeat this. Can you see 1 by 2 constant? That is outside the integral symbol. Within integration, what is remaining? 1 into x square. Say x square by 1 plus x square, this one, 2 taken out already, dx remaining. So now the only question, only challenge is, how do you integrate x square by 1 plus x square dx? Here actually this comes under partial fractions, but do not apply partial fractions. It can be easily bypassed by adjusting the numerator. Can you see the denominator? What is the denominator? 1 plus x square. What is the numerator? Simply x square. So numerator also make x square plus 1, because the denominator there is 1 plus. Therefore numerator add 1 and subtract 1. Wait, I will continue. Therefore this step same, tan inverse x into x square by 2 minus half, same, integration of denominator, let it be 1 plus x square, numerator of this is already x square, we will add 1 and we subtract 1 in the numerator, and dx, and remaining part of this I will continue over here. Therefore this is equal to, say, this term as it is, tan inverse x into x square by 2, this minus half into, so this half into. Now I will open a bracket, and inside the bracket, of course, we can split, or first I will split this. It is, isn't it, my dear students? First term I can take x square plus 1. So this much I can take x square plus 1, divide by 1 plus x square. Now divide by 1 plus x square, and second term I can take minus 1 by 1 plus x square. Here minus 1 by 1 plus x square, whole bracket I will close, and of course into that of dx. Wait, therefore this can be rewritten, tan inverse x into, say, x square by 2, same, x square by 2 same, minus half same, this is, you see, in bracket, integration of, say, x square plus 1, 1 plus x square get cancelled, we get just 1 here, minus 1 by, this is as it is, 1 plus x square dx, then bracket, or I will split it into two integrals, say tan inverse x into x square by 2 as it is, minus half as it is, and now I split it into two integrals. One is integral of 1 dx, integral of 1 dx, and minus integration of second 1 by 1 plus x square dx, and thus we can integrate. Therefore, maybe the last line, tan inverse x as it is into x square by 2 as it is minus half into this. I will write integration of 1 dx is x minus integration of 1 by 1 plus x square dx is tan inverse x and plus constant of integration c. But if you want this minus half, you can multiply inside and write minus half into x minus into minus plus half tan inverse x, or you can leave it here itself. So this carries 3 marks question, 3 marks using integration by parts. Here is the third question from model question paper 3. And you can read in the question, integral of x minus 3 into e power x. At the moment you see this e power x, it should come under this formula. So I will write in the rough work side. Integration of anything of this type, e power x into f of x, a function plus f dash x, its differentiation. F dash x means its differentiation, dx. Then answer is this e power x into this f of x. E power x into f of x plus c. Therefore, I should rewrite, this integrand in this form. Say, I will start here. I is equal to what they have given, x minus 3 into e power x by x minus 1 whole cube dx, and I will give the clue. First, this e power x, let me write first front, and now I tell you, see please, this you understand clearly. Observe the denominator. Denominator is x minus 1 whole power 3. In your mind, ignore power 3. What is remaining? X minus 1. Numerator, what is given? X minus 3. This minus 3, you write minus 1, minus 2. I will repeat. Since here x minus 1, numerator x minus 3, you write x same, but minus 3, you split, break as minus 1, minus 2. And you know, minus 1 plus of minus 2 is minus 3. Denominator same here. This is x minus 1 whole cube. Dx here, wait, I will continue. It is integration of e power x into, I will start in a bracket and I will split. Say, this term, x minus 1, divide by this full, x minus 1 by x minus 1 whole cube. This minus 2 by this x minus 1 whole cube into dx. And in the first ratio, see, one x minus 1 term gets cancelled and remaining is integration of e power x. Here 1 by x minus 1 whole square remaining. Square is remaining. Here instead of minus, I will write plus, because we need plus in the middle, plus. Where is minus 2? Now I write minus 2 by this side, I write x minus 1 whole cube as it is, dx. Therefore, wait. Now, my dear students, in this exercise, it looks like, in this exercise, our x minus 1, our 1 by x minus 1 whole square, this is f of x. This is f of x. This is f of x. And this is its derivative, f dash x. Say, I will show you in the rough work side only. Listen, wait. So therefore what happens in this exercise here, our f of x is 1 by x minus 1 whole square, and which can be written x minus 1 power, this whole square can be written minus 2. Therefore, now it's a differentiation. I mean differentiation f dash x. Apply chain rule. What is the differentiation of x minus 1 power minus 2? Start from the power. Minus 2 into x minus 1 power minus 2 minus 1. That is minus 2 into x minus 1 power minus 3. Therefore, minus 2 divided by, this bring it to the denominator, x minus 1. Negative power, when you get it to the denominator, becomes positive. So that is term present here. Minus 2 by x minus 1 whole cube. That only I said f dash x. Therefore, this is f of x. Say 1 by x minus 1 whole square. Apply the formula. Formula says it should be e power x written as it is. Therefore, I will write e power x as it is into f of x. F of x should be written. F of x is in this exercise 1 by x minus 1 whole square and plus c. Kindly go through the solution. Here is the fourth question. I have selected from last year's model question paper carrying 3 marks. Say find the integral of 1 by a square plus x square with respect to x. Say I will start here. I means given question, given integral of 1 by a square plus x square dx. In this exercise, students usually commit a mistake. They think that this problem is under partial fractions. No, this is not under partial fraction because here we have plus x square as well as plus a square. When both plus x square plus a square, we cannot factorize. Therefore, this is not under partial fraction. Instead, it is under method of substitution. So, I will go to the rough work side and I will do the substitution. Put x is equal to, so whenever this kind of term is present, a square plus x square, then put x equal to this small letter a into tan theta. A into tan theta. Say this equation I differentiate with respect to x on both sides. Say d by dx of x is equal to d by dx of a into tan theta. D by dx of x is 1. D by dx of a constant. D by dx of tan theta is secant square theta into, since this theta and this x variables are different, it becomes implicit differentiation. So into d theta by dx we should multiply, or this dx cross multiply here. It is dx is equal to a into sec square theta d theta with these changes. One change is this, one more change is this. I will come back to my main question side. Say 1 by, it is a square plus, so x, I put a tan theta whole square, dx is, I will write a secant square theta d theta, and this I write integral of 1 into a secant square theta, say as it is, a secant square theta d theta divided by, this is a square plus, say a square, and this is tan theta whole square, tan square theta. And now it is again a secant square theta d theta as it is. In the denominator, a square common. So from a square, take a square common, 1 remaining, plus from a square tan square theta, take a square common, tan square theta remaining. Therefore, say 1a get cancelled and I will continue. It is integration of numerator. After cancelling a, secant square theta d theta remaining. Denominator, one more a remaining into 1 plus tan square theta is secant square theta. Thus, now secant square theta cancelled and there is integral of 1 by a d theta remaining. 1 by a outside. Integral of 1 d theta remaining. And integral of 1 d theta is theta plus c constant of integration. Meantime, I should substitute back for theta, and that I will do here. See, we have made a substitution, x equal to a tan theta. Therefore, isn't it x by a? This a comes to the denominator, is tan theta, or this tan transpose, isn't it? You get tan inverse x by a. Tan inverse x by a is our theta, and therefore I will substitute here 1 by a as it is. Theta I will substitute tan inverse x by a plus c. So this is the 3 mark solution. Kindly go through the solution.